The last special data type that I want to tell you about today is dates. And dates in R are stored in a very unusual way, and they require some particular handling. So I want to tell you a little bit about this package called lubridate that's going to make your life a little easier. So some common things you might like to do with dates. Well, you might have in your data set a variable that you know as a human to be dates. But to R, something like April 2nd, 1989, just looks like a string. It just looks like characters. But you might want to let R understand that in fact this is a DateTime object. This thing is a date, not just a word. You also might want to take that object and find the weekday, like what day of the week was April 2nd, 1989. I can tell you it was Sunday. What's the month? What's the year? You might want to extract these pieces of information from your date data. Another thing that you often need to do is convert between time zones if you're trying to figure out what's going on with timing of something, and you don't really want to manually do that process of time zone conversion. So for this, we'll use the package lubridate. This package, the name is very polarizing. A lot of people consider it to be the most clever name of an R package, but some people find it a little strange. It does make using dates a little easier, so I suppose it's evocative. Lubridate does install with the tidyverse. You don't have to install .packages that, but it actually doesn't load. When you do your library tidyverse, that shortcut, it's not one of those default packages. So if you want to use it today, you'll have to put a library statement into your R Markdown file. Now with these DateTime objects, I use this word DateTime as a kind of a catch-all. It's actually true that there are 3 classes in R commonly used for dates and DateTimes. One of them is called date, and that feels like, duh, good name. The other 2 are POSIX LT and POSIX CT. I don't know what those stand for. I think those names are not great because they're not very informative. I'm sure there's good historical reasons for them. Doesn't matter. For you, don't worry about it. Just know that if you see a date or a DateTime or a POSIX type object, that's just yet another object class. It's not an integer, it's not a string, it's not a double. It is a DateTime object. And so back in the old days, so to speak, the pre-lubridate days, the way that you'd take a string or take some data and convert it to be understood as a DateTime object, you'd have to get the formatting just right. So if you had your data in your data set in this particular form, I've seen here, 1989-04-02, we can see that if I run as.date, that function, on a string of this form, then R understands that this is a DateTime object. If we pipe that over and look at the structure, we see that the type is date. And we can see the value right there. And so that's great. There's also this function as_DateTime that does kind of the same thing. It takes a string of perfect form. If we look at the structure, now you're seeing that funky POSIX CT business. Regardless, you should interpret that as, oh yes, we have made a DateTime object. But how often in your life do you get a data set and everything is typed in exactly the format that you wish it were? Pretty much never. A lot of us using R would be out of a job if that were the case. So you can hope that your data comes in this perfect year, month, day form that we see right here. But if you hope that and it doesn't work out, you're in a little bit of trouble. So lubridate comes with some nice functions that are kind of shortcuts. So one shortcut is you can actually manually make the date. You can hand to R, here is a year, a month, and a day, and R will convert this to a DateTime object. So we see here, it's converted to that string format, and it's understood to be a DateTime object. There's also these nice shortcuts, MDY, month, day, year, and you can use those letters in any order at all, that tells R to read this string, looking for a month, and then looking for a day, and then looking for a year. So now if I have that kind of human-readable form, April 2nd, 1989, R says, I found a month, I found a day, I found a year. Under the hood, turns it into a DateTime object, and now we see it in standard form. There's also this parse DateTime. Parse DateTime is kind of like a Hail Mary. If you couldn't get one of these MDY type functions to work, or if you didn't create the date manually, you can try to parse it. And so here we can see that we're trying to parse a particular string that we as humans can see is April 2nd, 1989. And we do have to tell it, here comes a month, a day, and a year, but it had some trouble. So dates are still kind of a problem. Dates are still very, very difficult. They can often come in different forms. You can often get a data set where some of them are written in one form and some of them are written in another form. This is one of the most challenging object types to process in R. So I want you to get some practice with these functions today, and I'll hope that you don't run into anything too horrible in your lives, but we'll at least learn how to handle some of the most common challenges with dates. So one thing I want to point out before I send you off to learn independently is probably the most common mistake I see. What is wrong here? I've used the as_DateTime function, and I've given it this date in perfect form. So now we're not dealing with that problem where it's human readable but not computer readable. I've given it that very specific format. And I said, July 4th, 2020, and you didn't get an error, you didn't get a warning, it perfectly processed into a DateTime object of January 1st, 1970. What happened? Well, let's think about making that date object before we convert it to a DateTime. So if I make my date 2020-07-04, let's rewind to like 3 minutes ago before you knew about DateTime objects. What does this look like to you? This should look like 2020 minus 7 minus 4. And indeed, R is still able to do subtraction, and it says, well, I can do that math. 2020 minus 11, that's 2009. It's a number. So then it took that number, and it fed that number right here. It did this math, and then fed that math into the as_DateTime function. What's wild about this as_DateTime function is that you can give it a number, and it considers that number to be the number of seconds since 1970. Why? I don't know. Computer programmers decided that January 1st, 1970 at midnight, that's starting, and we'll count up or we'll count down from there. So the DateTime object of 2009 is 2009 seconds since midnight, January 1st, 1970. And that's why this got converted to the date of 1970, not what you wanted. So be aware that these DateTime functions, they do want strings. Even if those strings contain mostly or exclusively numbers, they want a character object. If you give them a numeric object like this one, it's going to do some weird 1970 seconds calculation. Your game is going to get all thrown off. So having given you that cautionary tale, let me set you loose upon the cheat sheet and the resources on the internet. I want to remind you that with all these where I've asked you to learn for yourself, that doesn't mean that you can't check answers. That doesn't mean that you can't ask me questions. Please absolutely post your answers on the course Discord, check in with me, ask people on Reddit or on Stack Overflow or whatever you prefer. With these types of check-in exercises, there is no such thing really as cheating. I want you to get to the answer in your own way. Having said that, let's talk about lubridate. So again, I want to remind you, think about object types, data types, object structures. What's the input? What's the output? So you'll notice that lubridate has 3 really similar functions. Year, years, plural, and d-years. What is the difference between those 3? Now the first 2 are the most important, but see if you can figure out d-years as well. And I also want you to think about what time zone does R think that dates are in? So earlier on, I read that date, April 2nd, 1989, my birthday, into R. What time zone did R think I was born in by default? Because I didn't tell it which time zone. There are these 2 sort of pipe-looking functions with percents around them. One of them is percent within percent. The other one is percent dash dash percent. They are used in somewhat similar context. See if you can figure out what's going on with those guys. They aren't really crucial. You can do all of this week's tasks without them, but they give you a really cool and elegant shortcut if you can figure them out. And then lastly, that parse DateTime function, we saw it break. Try it on something and try not giving it the day. What happens? What happens if you leave off a day or a month or a year, even when R expects those things? Do some experimenting there.